this video, we're going to review things from chapter 9 in the Algebra 1 class that I'm teaching. And so the specifics of what we're going over will be graphing quadratic equations and functions, and using the quadratic formula, using the discriminant, and at the very end is graphing quadratic inequalities. So this is not, especially if you're in Algebra 1, this is kind of some heavy-duty stuff, so hopefully I'll do a good job of explaining it so that you can understand what's going on. So these first four questions are about being able to see what we can tell from just an equation about what the graph of a quadratic function would look like. So on part A, it says to tell whether the graph opens up or down. And so normally that would be really easy if we knew what the graph looked like. But it's also really easy if we just know what to look for in our equation. So if we look at what's in front of x squared, the number, or if there's not a number, we're really just looking at whether it's positive or negative in front of x squared. If it's positive, that causes our parabola to open up. And if it's negative, like it is on the second one here, then that causes our parabola to open down. So for A, our parabola opens up because it's a positive 3. And on 2 for A, we'd say it opens down because it's a negative 2. The next part asks us to identify the coordinates of the vertex. To find the vertex, we use the formula negative b over 2a. And so that means that we need to know what a, b, and c are. A is what's in front of x squared, b is what's in front of x, and c is the number left over. If your equation's in standard form, where it goes squared, not squared, and no x, then a, b, and c go in whatever order the numbers are in. So to plug in and find the vertex, we're going to do negative b, so negative 24, over 2 times a, which is 3. So negative 24 divided by 6, which is negative 4. Now if we were graphing this, we would put negative 4 in a table of values and plug in a whole bunch of numbers so that we could get points to plot. But since we're just asked to find the vertex, we don't need the whole table of values. We just need to plug in negative 4 specifically to get our y value. So we plug in negative 4. When you plug in negative numbers to an equation like this, you are supposed to put them in parentheses. There are times where it's not a huge deal, but in particular where we need parentheses is around this negative 4 that's being squared, because negative 4 as a whole being squared makes that negative go away. And if I did not have parentheses and just had a negative and a 4 and then a squared, like this is meaning square the 4 and make it negative. So we want to make sure that we understand that all of this negative 4 is being squared because we're plugging negative 4 into x, which is being squared. So this would be 3 times 16, and then 24 times negative 4 is negative 96, and 3 times 16 is 48, so 48 plus 46 is 94, and 94 minus 96 is negative 2. So the y value of this is negative 2. C asks us to tell what the equation of the axis of symmetry is. And that comes from our vertex. The axis of symmetry, if we do know what our parabola looks like, this parabola opens up, it's got a vertex down here. The axis of symmetry is this vertical line that splits our parabola into two halves that are mirror images of each other. And so we know that this is our vertex down here, and what we need is x equals the x value from our vertex. So the line that's splitting this parabola in half is x equals negative 4. So once you know from negative b over 2a what the x value of your vertex is, you put that right here with an x equals. If you don't have the x equals and you just write negative 4 on a question like this, you didn't actually answer it. That's not an equation if you just have negative 4. So the x equals is important because it tells us it's a vertical line, not a horizontal line, which would be y equals. Let's look at 2. So on part B, because we already did A because -2 makes it open down, we are going to do -b over 2a. So -16 over -4, which is +4. And actually, as soon as I know that, I can go ahead and fill in what c is. And then I just need the y value that goes with 4. So I plug in 4. And get -32, because it's 16 times -2, plus 64 minus 28. So this is 32 minus 28, which gives us 4. So that is our vertex 4, 4. So at this point, if you feel like you know what you're doing, pause the video and try to do these next 2 problems on your own, then start it back up and see how close to right you were. On A, we look at what's in front of x squared, and it's negative, a -1, and so that means that this opens down. Part B, let's see, A is -1, B is 4, C is -6. So we're going to do -b over 2a. So we get -4 over -2, which is +2. That is our x value. And then we plug in 2 to get our y value. Now here's something that people will have some issues with. So up here I said, hey, put this in parentheses so you know that it squares the negative away. And we did that because we were plugging in a negative number for x. Down here, we have -x squared. The negative is not being squared. If it was, we wouldn't need it to be there at all. What's happening is we're plugging in a 2, which is being squared, and then being made negative from the negative in front. So this is a -4. And that's a weird thing maybe to get used to, but that's how it works, is that we square it and then make it negative. And anytime we have a -x squared that we're plugging into, that's what is going to happen. So it looks like I get -2 for my y value. So that's number 3. Number 4. The number in front of x squared is a +1, so it opens up. And then we label A, B, and C and plug into -b over 2a. I don't know why I just wrote it again, but that's cool. So we get -6, which is going to make it turn into a +6. That hasn't happened to us yet in this section. That's how we deal with that. And then 2 times a, which is 1, so that this is 6 over 2, which is 3. So the x value is 3. And then I'm going to plug the 3 in. And get 9 minus 18 plus 13, which is 4. So that's our answers on number 4. Okay, the next kind of problem that we're going to look at is graphing quadratic equations or functions. It says in the instructions, identify the vertex and use a table of values to sketch the function. When you see something like this where it says identify the vertex, typically what that means is that your teacher wants you to tell them what is the vertex. And then it says state the solutions of the function when y equals 0. So we're supposed to be graphing y equals negative x squared. Then once we have the graph, we're going to pretend that this is really 0 equals negative x squared. And that means that we're going to find the solutions of that by looking at the graph and seeing where it goes through the x-axis, since we'll have a graph to look at. That's a pretty easy way to find the solutions. So let's look and find the vertex. Since this is a -1 in front of x squared, a is -1. When we don't have the other terms, then b and c would be 0. So that means that I'm doing -0 over 2 times -1. -0 is the same as +0. 0 is not either positive or negative. And more importantly, 0 divided by anything is 0. So the x-coordinate for our vertex is 0. There are different ways of learning how to graph quadratic functions, but this is one way to do it, and this is the way that I think is probably easiest at the beginning, is that once we know that this is 0, we're going to stick it in the middle and pick things that are more negative, 2 things that are more negative, 2 things that are more positive than our coordinate for our vertex, because parabolas have symmetry, and so we'll be able to use that to help us check our answer, our points, or just to do less work, one of those two. Sorry. Okay, so we're going to plug in all 5 of these into y equals negative x squared. So we could plug in -2, and so what happens is the -2 gets squared and becomes 4, but then gets made negative by the negative in front, so this is -4. What should happen is if I plug in this side of my table of values, I should get the same number, that I'm squaring the 2 and getting 4 and then making it negative, which makes it -4. Same thing should happen on 1 and -1. A -1 when I square it is 1, the negative in front changes it to negative. And then 0 squared is 0, and 0, if it's negative, is still 0. We're going to plot our points. And draw our parabola. And our identify our vertex is 0, 0, because that's the topmost point of our graph. Our solutions are where it touches, or horizontal axis, so it touches at 0. And our solutions to an equation are x equals whatever the x value is up here, which would be 0. So our answers to this is kind of a long problem. Our answer to this is the graph, because it asks us graph, it's the vertex, and it's the solutions. So lots of information here. Let's look at 6. So because there's not anything out to the side here, like not a normal number, it'd be like there's a +0, which means that a is the 1 in front of the x squared that's not really there, that we don't show. B is -2, and C is 0. And then we're going to use the vertex formula. So it's -b. Sorry, -2, because it's -b and b is negative, over 2a, which gives us 2 over 2, which is 1. And then we're going to pick 2 numbers more negative and 2 numbers more positive. And so what we can do, if we're confident that we've got the vertex right, and that we've picked our table of values right, is we could do things like, well, if I plug in 0, because that's easy, I get 0. And if this one's 0, that's 1 away from my vertex, then 2 should also give me 0 because it's 1 away from the vertex the other direction. This is the symmetry that was happening over here. And if we're confident in what we're doing with math, or if we know how to tell when we've done something wrong, then we can kind of rely on that as a way to do less work. So then I will definitely have to plug in 1. I can't get around that. That's 1 minus 2, which is -1. And then I can choose 3 or -1, or both to plug in. 9 minus 6 is 3. I will say that whenever you're doing like a quiz or a test, that can be a way that you can check to see if you're doing things right, is by plugging both of them in to make sure you get the same thing. But at the same time, no, I'm just going to go back and say, yeah, that's a good idea. Whenever it's a quiz or a test, that's a way to check yourself that you're not completely screwing something up. So -1, 3 is up here, 0, 0, 1, -1, 2, 0, 3, 3, and we draw our parabola as a nice curve, U-shaped or V-shaped, but hopefully without a point at the bottom. But anyway, the vertex is 1, -1. Our solutions, this time our graph goes through the x-axis twice. And so our solutions are here at 0 and at 2 is where it crosses. So x equals 0 and x equals 2. Those are both solutions. Let's look at a couple more. So again, if you're feeling pretty good about what we've done so far, you might think about pausing the video and trying these on your own to see if you can come up with the right answer. 8 does have a fraction, which causes some people problems, but give it a try. So this is A, B, and C. We're going to do negative b over 2a, and that gives us 8 over -4, which is -2. So that's what's going to go in the middle of our table of values. And we'll pick 2 that are more negative and 2 that are less negative. J, K, oh, never mind. I'm right. Don't worry. I know what I'm doing. -2. Okay. We want to pick 2 numbers more negative, 2 numbers more positive. 0 will be easy. When I plug in 0, this goes away, and it leaves me with -6. So when I plug in -4, I should also get -6. When I plug in -1, I get -2, because it's -2 times +1, plus 8 and -6, so that's 0. And that means that this should also be 0. And I plug in -2. And I get -8 plus 16 minus 6. So that's -14 plus 16, which is 2. And that goes right there. So I am going to plot these points. Draw my parabola, and then write out the 2 parts to my answer. The vertex is -2, 2. The solutions are x equals where it goes through the x-axis, which is -3 and -1. On 8, we've got A, B, and C. And this one's a little tricky because we've got a fraction that's going to make itself make things difficult a little more difficult. When we look at this, we want to do the bottom first and say, what is 2 over 1 times -1 over 2, which is a -1. -2 over -1 becomes a +2. So that is the x value of our vertex. and we've got two things more negative, two things more positive. And then we're going to plug things in. 0 is easy. It's just the last number, which is -3. And then 1, when I plug it in, is 1 squared is 1 times -1/2 is -1/2. 2 times 1 is 2. And so we have -1/2. I would put these two together as -1. -1/2 minus 1, you'd add those together and get 1/2, and then it's negative. So -1/2. And we're going to plug in 2, which will actually be a little easier because we'll be able to cancel out our fraction. So this is 2 squared, which is 4. 4 times -1/2 is -2. -2 plus 4 is 2, minus 3 is -1. And so now we've got all our points, and we can graph this. 0, -3, 1, -1/2, 3, -1/2, 4, -3. So there's our parabola. Our vertex is 2, -1. Our solutions are where it goes through the x-axis, but this is below the x-axis, and whenever it continues, all of our points from here on out would be below what we've already got, which means that there are no solutions to this equation. So we would say no solution, because it does not ever have a place where y would equal 0, which is what it was asking us about in the instructions. I've got 2 more here that I'm going to run through pretty quickly, because at this point, again, it's more about practice than anything. Really, you should pause the video and try to do these on your own if you're still having problems, and then check back and see if you can figure out what you might be doing wrong. So we get -8 over 2 times 1, which is -4. That's the middle of our table of values. So I pick other numbers. So I'm going to skip through the calculations and just tell you what these would be. So if you're making a mistake, you will need to look for that on your own. This is -6, 0. -5, -3, -4, -4, -3, -3, -2, 0. Connect it all together and write our vertex and our solutions. Our vertex is at -4, -4, and our solutions are at -2 and -6. Because that's where it goes through the x-axis up here, is at x equals -2 and x equals -6. And finally, as far as graphing goes, then we'll move on to, cool things like the quadratic formula. It'll be great. This is 1, 6, 8. And so we've got -6 over 2 times 1, which is -3. It's the middle of our table of values. So -4, -5, -2, -1. And I'm just going to, again, fill the numbers in. And if you're struggling to figure out how to get these numbers, then, if you have me in class, then come ask me. If you are watching this on the internet and we have no way of seeing each other, then I believe in you. I think you can figure it out. You can do this. And I did not mean to imply that I didn't believe in my own students, because I do. But they can take the lazy way out and come ask me. Anyway. So our vertex is -3, -1, and our solutions are -4 and -2. So that's how we graph, and that's how we would talk about the solutions of a graph. Now let's talk about the quadratic formula. Just as a frame of reference here, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And just like we did in the earlier problems with graphing, we're going to label a, b, and c. This time though, later on, we'll get to some problems where it's not written correctly and we have to move things around so that we can figure out what a, b, and c should be. So, since we know a, b, and c, b is 1, since there is an n, there's one of them, so it's b is 1. We're going to fill this in. X equals negative b, so negative 1, plus or minus the square root of b squared, so 1 squared, minus 4 times a times c over 2a. And we'll see what we can work out on this. So underneath our square root, we've got 1. 4 times 5 times 8 is 160. And then on bottom, we can do 2 times 5 and get 10. Now, depending on who your teacher is, they might want you to take this problem different ways. But for me, what I want us to see is that this is negative 159 when we subtract. And that means that there is no solution to this or there's no real solution to this more specifically. I can't square root a negative number and get a real number. It gives me an imaginary number. So at least as far as Algebra 1 goes, for most people, that means we'd stop and say no solution. When you do Algebra 2, then you will probably go on and find the imaginary solution. So you have something to look forward to there in a future class. 12. So we're going to label A, B, and C. A is 1, B is 3, C is negative 10. And we're going to do, so I wrote x equals over here. Really that should be n equals because n is the variable in our problem. And so this should really be v equals, not x equals. But I don't know that many people really make a big deal out of that. This is negative 3 plus or minus the square root of 3 squared minus 4ac all over 2a. And so when we simplify, we go into the radical and we say, what can we do here? We've got 9 plus, because it's negative 4 and negative 10, make it positive, and that ends up being 40. So 9 plus 40 is under our square root, so we get the square root of 49, which we know the square root of 49 is 7. And if we're able to get rid of our square root like that, then we're able to write this out as two different problems. We can say negative 3 plus 7 over 2 and negative 3 minus 7 over 2, and we can actually get two numbers for our answers. This would be 4 over 2, which is 2, and this would be negative 10 over 2, which is negative 5. So our answers on this are 2 and negative 5. (13) and 14 is where we start having to pay more attention to things like the fact that, oh, this has a number over there on the right and we want it to equal 0. So we need to move that number by adding or subtracting. What that does is it changes c, which we might have originally thought was negative 5. It changes it so that it's the correct c, which is negative 2. So it's really important that we make sure that it's already in standard form where it equals 0 and everything's in the right order, so that we label A, B, and C correctly. Because if you can't label A, B, and C correctly, good luck on the rest of the formula. So x, or n in this case, equals negative 3 plus and minus the square root of b squared minus 4ac all over 2a. So that gives us negative 3 plus and minus the square root of 9 plus, because there's 2 negatives there, 12 times 2 is 24. I would have to say one of my least favorite parts of the quadratic formula is doing the multiplication underneath, because sometimes we end up with big numbers that we would have to go work out to the side what they are, and I personally am not really a fan, but hey, to each their own. -3 plus or minus square root of 33 over 6 is our answer. If we can't get rid of the square root, then we're allowed to basically just stop, unless your teacher has specified that they want the decimal answer, and then you'd plug this into the calculator. But otherwise, there's not anything more useful we can do. Now, some people might try to simplify here, this -3 and this 6, but that doesn't work, because if we do anything where we try to simplify, we would have to think of this like they're actually two different fractions. And we'd have to say, okay, can I simplify both of these? And if I can't, then I don't want to simplify at all, because I want to leave them as one fraction. I don't want to split them up, because that's actually less simple to have two fractions instead of one. So the fact that this part does simplify and this part does not means that I don't want to think about simplifying it at all. I don't want to do -3 over 6. Also, I didn't say this, I kind of did it in my head. We should check to see if we can simplify the square root of 33. There isn't a square root of 33, but we would ask ourselves, is there something I can divide into it that would that we can take the square root of? And there isn't, because square root of 33 is 3 and 11, and those are both prime. So on 14, we would subtract the 3 over to the other side. And I would say that at this point is where, if you have not already tried some of these on your own, that you might think about pausing the video and trying some on your own and then checking to see how you're doing. A is 2, B is -2, C is -1, and we get V equals negative B, so that'll switch to a positive on our next step. This -2 that we're squaring should be in parentheses to say, hey, I'm squaring this whole -2 and not just part of it. And then we've got -4 times A times C, and it's all over 2A. So what I want to do is make this negative turn into a positive. And I want to say 4 plus 8, which is 12. And then on bottom, I've got a 4. Again, I cannot simplify 2 over 4, but what I might be able to do is simplify the square root of 12, and that might let me simplify. So if I simplify square root of 12, I'm looking for something that divides into 12 that has a square root. That ends up being square root of 4 times the square root of 3. I can take the square root of 4 and get 2. I cannot take the square root of 3, so I leave it under the radical. So this changes into 2 plus or minus 2 square roots of 3 over 4. So like what I explained a second ago, if we can simplify, what we're thinking of it like is two fractions, and we're saying, can I simplify both of these in the same way? And I can, because in both of them I actually have the same thing, 2 over 4, which simplifies to be a half. So what's happening is that we look at these three numbers, and if we can divide them all by the same thing, we do. There's not a number right here. We can't do anything, like on the last one. But there is, and they're all divisible by 2, so we divide them all by 2. When we divide them all by 2, make sure that you say, oh, 2 divided by 2 is 1, not nothing. Because if you don't put that 1 there, your answer is incorrect, which would be sad, because you came so far with things that were right if you got up to that point. We've got 2 more. So the biggest thing on these 2 is make sure that you get everything on the right, on the correct, or on the same side, not the correct side. There's not a correct side. Get everything on the same side. And then at the end of this, you can check your answers to see how you're doing. I recommend, like I said, pausing the video to see if you can do it yourself. So I am going to subtract k squared, and then make sure you rearrange this. The k squared needs to be first, and then the k, and then the number, so that we know that a is -1, b is -2, and c is 6, because the order matters, as it so often does in mathematics. This is k equals -2 plus and minus the square root of -2 squared minus 4ac all over 2a. And that means that we can simplify this by making this a +2. This is 4 plus 24, which is 28. And it's all over -2. We can simplify the square root of 28 because the square root of 28 has a 4 in it. So that would be 2 square roots of 7. So we make that change. And then we are going to, we actually can do this, the best way to do this is to divide by -2, so that this negative is no longer on the bottom, and that would give us a -1 plus and minus square root of 7. Now, if you had 1 plus and minus 1 square roots of 7 over -1, technically that's still right. It's just kind of weird to have like an over -1 situation. And so typically we would want to divide the top by -1, which is how we get this negative. And the second part of this, since it already has a plus sign and a minus sign, dividing by a negative doesn't actually do anything to that. And our final quadratic formula problem is 16 here. We would start by subtracting 4. And get a, b, and c. And this is n equals -3. Plus and minus the square root of -3 squared minus 4 times a times c. All over 2a. So this is 3 plus and minus the square root of 9 plus 16, which is 25, and I didn't need that big of a square root. The square root of 25 is 5. So 3 plus and minus 5 over 2. This happened to us earlier, that since we got rid of the square root, we can make this go into two different situations where we have 3 plus 5 and over 2, and then 3 minus 5 over 2. So 8 over 2 is 4. -2 over 2 is -1. And those are our two answers. Often when we talk about the quadratic formula, we talk about the discriminant. The discriminant is part of the quadratic formula. It's b squared minus 4ac. And what it does is we'll get a number, and that number tells us how many solutions there are and whether or not they are real or imaginary. If we get a positive number, there are 2 real solutions. If we get 0 exactly, it's 1 real solution, and if we get a negative number, it is no real solutions, because they would be imaginary. So we do a, b, and c. So a is -1, b is -9, and since there's not a normal number without a letter or anything, c would be 0. We plug this in as -9 squared minus 4 times -1 times 0, and get 81 minus 0, which is 81. It says find the discriminant, which means we actually have to find the number. If it told us to use the discriminant or just said state how many solutions and didn't really say anything about finding the discriminant, we wouldn't actually have to necessarily go all the way and write the number, although in this case it's not hard, but it says find the discriminant. Hey, here it is, it's 81. And since 81 is positive, there are 2 real solutions. So it's like there's 2 answers here. That the number itself and then the interpretation of that number. on the rest of these, the same kind of thing happens. So feel free to try it on your own if you want to. A is 1, B is -4, C is 4. It's really important that we pay attention to negatives. They make all the difference here. And just paying attention in general can make all the difference in math. We get 16 minus 16, which is 0. When I get 0, that means that there is one real solution. And then on these last two, it looks like we've got some moving around to do. Make sure when you subtract 7v that you know that it goes in the middle, not at the end or the beginning, because that's standard form is squared, not squared, and number. And so A is -6, B is -7, C is -9. So we're doing -7 squared minus 4 times -6 times -9, which is 49 minus 216. And when we subtract those, which we have to because it actually says find the discriminant, when I subtract those, I get -167. So there are no real solutions because we're not able to take square roots of negative numbers. And that's what would happen if we stuck this into the quadratic formula. And last of the discriminant. And this could be any of the three because we already had one of each. So we would add k squared and put this in the right order, k squared, and then 6k, and then 9. We got a, b, c, b squared minus 4ac, 36 minus 36 equals 0. And when it's 0, there is one real solution. If you're watching this video and you're in my class, this is the end of 9.6. So if that's where we stopped in class and we didn't do 9.7, this is where you should stop the video. But if you are in a class where we did do 9.7, then stay tuned for just a moment to see 9.7. 9.7 is about graphing quadratic inequalities. So we're going to take the things we know about linear inequalities and figure out how to apply them to quadratic inequalities. And our first steps will just look a lot like, what were those numbers? A lot like 5 through 10 did, where we're just graphing the parabola. The difference is we need to check to see if it's a dashed or solid line, and then we need to shade either the inside or the outside of the parabola. So we label this A, B, and C, and fill in our vertex formula, negative 8, because it's negative b. 2 times -2, we get 8 over -4, which is -2. We pick numbers more negative and numbers more positive. We plug it in. And so at this point, I'm just going to say what they are, and you can practice getting that on your own. -4, -11 is right here. -3, -5 is right here. -1, -2, -3, and back down. Before we actually fill in the parabola part of this, make sure you look and see that it is equal to, so it is a solid line. So unlike before where we cared about where it goes to the x-axis, what we care about now is we're going to shade either inside or outside of this parabola. The way this works is that less than, if I took a point on my parabola and I thought, hey, less than is below, and I drew an arrow to where I think below is, which is down, this is where I would shade this parabola. This is less than my parabola. Now, if that was not something that we knew or that made sense, the other way is to pick a point. 0, 0 is an easy one to pick, and plug it in up here and see if it's true or not. 0 is less than or equal to -11. Is that true? No, it's not. And so if what we get is true, then we shade that part of our graph. If what we get is false, like in this case, well, that tells us to shade on the opposite part of our graph. So since this point was outside and was not true, we should not shade outside. we should shade inside our parabola. And the same kind of thing is going to be the case for the rest of these problems. So A, B, C, negative 2 over 2 times negative 1 is 2 over negative 2, which is negative 1. We're going to fill in a table of values. And work out what these are. We get negative 2, 1, 2, 1, negative 2. So I'm going to graph this. Notice that this is not equal to, so this will be a dashed parabola. I didn't draw that in the right spot. That should be negative 3, negative 2, negative 2, 1, negative 1, 2, 0, 1, 1, negative 2. So I'm going to draw that dashed. And it's greater than. And so if I put my pencil on my parabola and draw up, that's the direction of greater than, so I'm going to shade outside of my parabola. Or I can pick a point. 0, 0 works. We just can't pick a point that's on our parabola. So I can't pick 0, 1 because it's on the parabola. 0, 0, I have 0 is greater than 1. 0 is not greater than 1, so we didn't shade where 0, 0 was, which is inside. We shaded the opposite, which is outside. At this point, you might try pausing the video and doing this on your own to see if you can get it. We get negative 6 over 2 times 3, which is 6 over 6, which is 1. And that gives us 0, negative 1, 2, and 3. So we've got 16, 7, 4, 7, 16. And so notice that this graph is by 2s. So negative 1 is in the middle between 0 and 2. Then 0, 7 is between 6 and 8. 1, 4, 2, 7. 316. So if your parabola looks funny, make sure that you paid attention to the scale the whole way through. I started off making this solid and switched to dashed because that's what it is, so whoopsie daisy. It's greater than, so the points that are greater are the points inside, because if I put my pencil on the parabola and draw up, that's the direction. That's where the arrow is that I would shade. We can also check 0, 0 or any other point we want to. 0 is greater than 7 is not true, so that's why we're not shading where 0, 0 is. Now I've been able to use 0, 0 on all of these. If I couldn't, if I picked a number like a point like 2, 2, we would have to say 2 is greater than and then plug the 2 in on this side and figure out what that would be. And it should be a false statement because it's outside the parabola and that's not where we needed to shade. But whenever you actually have to plug in something other than 0, 0, make sure that you make the y value be whatever y value you picked. Now, last one. A is 2, B is negative 16, C is 29. This is negative 16 over 2 times 2, which is 16 over 4, which is 4. So that goes in the middle. 2 that are more negative, 2 that are more positive. These end up being like big numbers, and that is frustrating. Like, you have to deal with some kind of big numbers in the calculations is what I mean. But you should end up with 6, negative 1, 3, negative 3, negative 1, 6. And this is a solid parabola. We're going to shade below the parabola. That's not my best parabola there. So we shade below, which means that we're shading this part of our parabola outside of it. Because if I put my pencil here and draw down, that's where my arrow is. Or I could pick, again, 0, 0, and get 0 is less than or equal to 29, which is true, And since it's true, I shade where 0, 0 is, which is outside of my graph. This has been a review of most of Chapter 9 in an Algebra 1 book, or in the one that I'm using. So thanks for watching. Have fun studying.